This question is about Group 2 and Group 17 or 7. Part A. Barium chloride can be prepared from barium hydroxide in a neutralization reaction. Write an equation for this reaction. State symbols are not required. When writing any equation, we need to start by writing our reactants. So we have barium hydroxide as one of our reactants, and this is a strong base. So barium hydroxide is BaOH2. The 2 because barium has a 2+ charge and the OH ion has a 1- charge, so you need 2 to balance the charges. Because it's a strong base and it's a neutralization reaction, we need to react this strong base with a strong acid. And we're making barium chloride, so our strong acid would be hydrochloric acid. We would then form barium chloride, BaCl2, and water. But we need to balance this equation by writing a 2 in front of our hydrochloric acid. We also need to write a 2 in front of our water. And to get this mark for part A, you need to have this entire equation correct and balanced. Part B. The reactivity of group 2 elements, magnesium to barium, increases down the group. Explain why. This is a very common 3-mark question with a set answer. Atomic radii increases down the group. Nuclear attraction will decrease alongside ionization energies. So to get the 3 marks for this question, you need to have written the 3 bullet points that I will demonstrate in a minute. So we need to say that atomic radii increases, nuclear attraction and ionization energy decreases. We could also add that electron shielding increases, but that would get you the same mark as atomic radii increases. So this is a very common question, and I would recommend learning these stages so that you can use them in the future and apply them to very similar questions. Part C. On gently heating, the compound KClO3 reacts as shown in the equation. This reaction is an example of disproportionation. Part 1. State what is meant by disproportionation and use oxidation numbers to show that disproportionation takes place. So firstly, with this question, let's define the term disproportionation. Disproportionation is where oxidation and reduction occur simultaneously of the same element. So if we look at the equation that we've been given and we write the oxidation numbers, potassium would always have an oxidation state of +1 and oxygen will always have -2. So we can continue writing that across the equation. So it would be chlorine that's going to have disproportionation. We can work out the oxidation numbers of chlorine. If we take equation or KClO3, the first bit of the equation, we have +1 plus -2 times 3, and that gives us -5. So the oxidation number of chlorine will be +5 in its reactant state. For the products, the first product, KCl, the Cl or chlorine will have a -1 oxidation state. If we look at our next product, we can work out the oxidation state of chlorine by having +1 plus -2 times 4. That would give us -7, making the oxidation state of chlorine +7. So, when answering the question, we can say chlorine and it has a +5 to -1 oxidation state and a +5 to +7. So if we link it to the oxidation and reduction, oxidation is the +5 to +7, and then reduction is the +5 to -1 change in oxidation state. Part 2, to get the 3 marks for this question, firstly, you need to have the correct definition, so oxidation and reduction of the same element, saying that it's chlorine, and then giving the example of reduction and oxidation using oxidation numbers or oxidation states. Moving on to part 2, what is a systematic name of KClO4? The answer to this is potassium, because there's the K, chlorate, because that's the name of a ClON ion. It doesn't matter if it's 4, 3, 2, so on. But we need to state the number, and the number will be 7. And that is because if we link back to the oxidation states, the chlorine's got an oxidation state of +7. To get the mark for this question, you need to have the correct name with the correct Roman numeral. Part D. 2 changes are described below. For each change, write an equation using state symbols. State and explain how entropy changes. Part 1. The reaction of aqueous barium nitrate with aqueous sodium sulfate. Write the full equation with state symbols and an explanation of entropy change. Okay, first let's write the equation. Barium nitrate, Ba brackets NO3 aqueous. We know this because we're told it's aqueous barium nitrate in the question, and then plus aqueous sodium sulfate, and that is Na2SO4 aqueous, and it produces barium sulfate, which is a solid, and sodium nitrate, which is an aqueous solution. And we need to balance by putting a 2 in front of our sodium nitrate. Entropy is a measure of disorder, and because we're forming a solid, entropy will decrease. And the reason for this is because BaSO4 solid, or barium sulfate, has less disorder. To get the 2 marks for this question, you need to write the equation correctly, balanced with the correct state symbols, and then you need to say that entropy is decreasing because there's less disorder because a solid is produced. Part 2. The change that accompanies the standard enthalpy change of atomization of iodine. We need to write the equation with state symbols and an explanation of enthalpy change. Okay, again starting with writing an equation, we want the standard enthalpy change of the atomization of iodine. That means we're going to form 1 gaseous iodine molecule. So we start with half iodine in a solid form, going to 1 iodine in a gaseous form. Entropy, well, in this case is going to increase because we're forming more gaseous molecules, so gas has more disorder would be our explanation for this question. To get the 2 marks for this question, you need to write the correct equation and have the correct explanation. So saying that entropy increases and gas has more disorder.